Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x to the power of y minus y to the power of x is equals to 17, and we solve this problem for all the values of x and y. So here first we rewrite this equation as in this form. So first we multiply and divide the exponents of both of these two terms by 2, and this will be written as x to the power of y, and its whole exponent is 2 over 2 minus this is y to the power of x, and its whole exponent is 2 over 2, and this is equals to 17. And here we use the nice exponential rule, and we move 1 over 2 inside the term, and it will becomes x to the power of y over 2 and its whole square minus this will becomes y to the power of x over 2 and its whole square, and this is equals to 17. And now here we convert this exponential equation into the simple quadratic of two variables form. So here we just take a is equals to x to the power of y over 2, and we take b is equals to y to the power of x over 2. So when we choose these two values, then our above equation is written as a square minus b square is equals to 17. So we need to solve this equation for the values of a and b. So you see that our left hand side with a very famous algebraic formula, and this is equals to a square minus b square equals to a minus b times of a plus b, and this is equals to 17. You see that our left hand side with a product of two factors, and left and right hand side with only one factor, so we write the right hand side as 1 times of 17. And now here we need to compare both of the sides, and we divide this equation into the one cases. So we have a minus b is equals to plus 1 and a plus b is equals to 17. So we call this is equation number 1, and this is our equation number 2. So we solve both of these two equations, and here first we find the values of a and b, and then we move backward and we get the values of x and y. So here first we sum up equation number 1 and equation number 2, and when we add both of these two equations we get a plus a equals to 2a. This negative b and positive b are gone, and we get 1 plus 17 becomes here 18. And now for the values of a, we divide both of the sides by 2. So when we divide by 2, we get here this 2 and 2 are gone, and we obtain a is equals to, this is 2 times 9 becomes 18. So we easily get the value of a is equals to 9. And now here in the parallel side, first we add both of these two equations, and now we subtract both of these two equations. So when we subtract these two equations, we get we just change the signs. This positive a negative a are gone, minus b becomes minus 2b, 1 minus 17 becomes minus 16. And now for the values of b, we need to divide both of the sides by minus 2 in order to get the value of b. So this minus 2 and this minus 2 are gone, and we get here b is equals to, this negative and negative term are gone, and we get 2 times 8 becomes here 16. So here we easily get the value of b is equals to 8. So here you see that we get the value of a is equals to 9, and we get the value of b is equals to 8. And now we move backward and we get the values of x and y. So the value of a is x to the power of y over 2. The value of b is y to the power of x over 2. So we put both of these two values here, and we get the values of x and y. So here first we put the value of a, it is x to the power of y over 2 is equals to 9. And here we put the value of b, it is y to the power of x over 2 is equals to 8. So now here you see that first we need to remove this square sign, and for this we take squaring on both of the sides. So when we apply squaring, this will become, this 2 and this square are gone, and we get x to the power of y is equals to this will becomes here 81. And now in the same pattern we again apply scaling on these terms, and we get y to the power of x over 2 and its whole square is equals to 8 square. This 2 and this 2 are gone, and we get here y to the power of x is equals to 8 square becomes here 64. So here we rewrite this equation as x to the power of y is equals to, we write 81 as 3 to the power of 4, and when we compare base and exponent we get, when we compare the bases we get x is equals to 3, and when we compare the exponent we get y is equals to 4. These are the values of x and y which we get here from first case. And now here from this case we have y to the power of x is equals to, we write 64 as 4 cubed, and now we again compare base and exponent, and when we compare the exponent we get x is equals to 3, and when we compare the bases we get y is equals to 4. So on both of these two cases we get the same values of x and y. And now in the next step we need to verify that is these values of x and y satisfied our given question statement or not. So for verification we need to copy down given question statement. Here it is x to the power of y minus y to the power of x is equals to 17, and we put the value of x and y here, and we get 3 to the power of 4 minus 4 to the power of 3 is equals to 17. And you know that 3 to the power of 4 becomes 81, and 4 to the power of 3 becomes 64 is equals to 17, and we easily get here 17 is equals to 17. This shows that both of the sides are equal. Now this means that the values of x and y satisfied our given question statement, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.